Hello math learners! Welcome to another session here in Math Learning with Sir Ash. We are finished with the overview of the system of linear equation as well as solving the system of linear equation using the graphing method. Now, how about solving system of linear equation by the use of substitution method? We have our four problems. We have our method. The question is, do you know how to solve them? If not, then tune in and finish this video and I will teach you how. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 8 of the Grade 8 Mathematics, which is all about solving system of linear equations by the use of substitution method. Now, in using substitution method, we are trying to solve for the solutions, right? There are three scenarios that will happen. If you have a value of your x and y, then you have a one solution. If your x or your y will be eliminated in your process of solving and the statement that will yield is true, then you have infinite solutions. But otherwise, if your variables are eliminated but you have a false statement, then it has no solutions. Now, let us consider some example. We have here x plus y is equal to 9, and the second equation is 3x plus 2y is equal to 22. Since this is substitution method, what we need to do is we will use one equation, we derive a value of the variable from that equation, and then we will substitute it to our second equation. How do we do that? This is the process. We have x plus y is equal to 9, right? So, I will try to yield the value of x. So, I will transpose my y. So, that gives me x is equal to 9 minus y. Therefore, this value of x will be substituted to my x in the second equation. My second equation is 3x plus 2y equals 22. So, what I do now is, I will change my x to this value. I will substitute it, giving me 3 times 9 minus y plus 2y is equal to 22. In this process, I only have one variable. So, therefore, I can simplify the whole equation and solve for the value of y. So, by doing so, I distribute my 3, giving me 27 minus 3y plus 2y is equal to 22. The common terms in this scenario is this one. Okay? So, negative 3y plus 2y, that will give me negative y. So, that is 27 minus y is equal to 22. I will transpose now my 27, giving me y is equal to 22 minus 27. 22 minus 27, that is negative 5. But here, I have negative y. So, I will divide the whole equation by negative 1, giving me y is equal to positive 5. So, I have a value of my y, which is positive 5. Now, getting the value of y, I need also to get the value of my x. So, now, I will use my y value to my first equation, giving me, okay, so that is x plus 5 is equal to 9 because my y is equal to 5, so that is my value. Therefore, if I solve this one, I will transpose my 5 here. That gives me 9 minus 5. So, 9 minus 5 is positive 4. Therefore, my solution is at 4, positive 5. Therefore, this system has one solution, and this one solution means that the nature of the system is consistent and independent. Easy, right? Now, let us consider the second example. For our second example, we have x minus 3y is equal to 3, and we have 2x minus 6y is equal to 5. So first, I will use my first equation. X minus 3y is equal to 3. I will derive one value. So I will still use my x because x here doesn't have any coefficient other than 1. Okay? So transposing it will give 3 plus 3y. So now, the value of my x is 3 plus 3y. Now, I will use this value of x to be substituted to my second equation, and that is 2x minus 6y is equal to 5. So, I will substitute the value of x here from here, giving me 2 times 3 plus 3y minus 6y is equal to 5. I will distribute the value of 2. So that gives me 6 plus 6y minus 6y is equal to 5. Now, the common here is these two terms, right? 6y minus 6y, that's 0. So, the only terms that are left is 6 is equal to 5. Now, the question is 6 equal to 5? No, that is wrong. That is false. Therefore, if the statement is false, then the system has no solution and the nature of your system is inconsistent. Easy, right? Now, let us go to the third example. Okay, math learners, we are down to our third example. We have 4x plus 3y is equal to 5 and 5x plus 2y is equal to 8. So first, I will derive first my first variable from the given equation. So 4x plus 3y is equal to 5. So earlier, I have been using the value of x for my derivation. Now, let me show you how about we will use our y. So I will transpose my 4x, that is 3y is equal to 5 minus 4x. Okay? I divide both sides by 3. Okay? So this will be cancelled. And the value of my y is 5 minus 4x over 3. So now, I will use this value to my second equation, and that is 5x plus 2y equals 8. 5x plus 2y is equal to 8. Okay? And then, I will substitute the value of y here. So that gives me 5x plus 2 times 5 minus 4x over 3 is equal to 8. What I need to do now is to distribute the value of 2 to my quantity. That gives me 5x plus 10 minus 8x over 3 is equal to 8. Now, for me to have a lesser difficulty in solving with a fraction, I will multiply the whole equation by my denominator so that I can eliminate it. So, 3 times 5x, that is 15x. So, 3 and 3 here will be eliminated. So, that brings down my 10 minus 8x equals 8 times 3, that is 24. Okay. So, combining like terms, 15x minus 8x, that is 7x, plus 10 is equal to 24. Then, I will transpose my 10 there, giving me 7x is equal to 24 minus 10. That is 7x is equal to 14. So, dividing both sides by 7, so my 7 will be cancelled. X will give me a value of positive 2. So, having this value of x, I will now substitute it to my first equation, which is here. So, this gives me 4 times 2 plus 3y is equal to 5. I am doing this for me to solve the value of y. So, this is 4 times 2, that is 8, plus 3y is equal to 5. Combining like terms, so I will transpose my 8. That gives me 5 minus 8. So, that is 3y. 5 minus 8 is negative 3. So, 3y divided by 3 and negative 3 divided by 3, that is y is equal to negative 1. Therefore, the solution of my system is at positive 2 negative 1. There is only one solution, therefore the nature of our system is consistent and independent. Easy, right? Now, let us go to our final example. Now, for our final example, we have 2x is equal to 5 times the quantity y minus 2, while the second equation is 1 over 5x minus 1 half y is equal to negative 1. Okay, so let's try to solve first the first equation. So that is 2x is equal to 5y minus 2. Okay, so I will distribute my 5. That gives me 5y minus 10. I divide both sides by 2, so I can yield a value of my x. So x is equal to 5 over 2y minus 5, because 10 divided by 2 is 5. Okay, so now I will substitute this to my second equation, but let's try first to write our second equation. We have 1/5 x minus 1/2 y is equal to negative 1. Now, it is very difficult to use fractions, right, as coefficients. So, let's try to transform this as an equation with just integers. So, how do we do that? We multiply the whole equation by its LCD. And what is the LCD of 5 and 2? That is positive 10. So, I will also multiply positive 10 here. So, 10 times 1/5. So, 10 times 1 is 10 divided by 5. That is 2x. 10 times 1/2. So, that is, what is the 1/2 of 10? That is 5. So, minus 5y. And negative 1 times 10, that is negative 10. So, now I have my second equation like this. And this is way cooler to solve than this one, right? So, now I have the value of x like this. So, I will substitute. So, 2 times 5 over 2y minus 5 minus 5y is equal to negative 10. I just substituted my x with my x in the first equation. Okay, so now I will distribute 2 times 5, that is 10, divided by 2, that is 5y. 2 times negative 5, that is negative 10, minus 5y is equal to negative 10. Now, I will combine like terms. 5y minus 5y, that is 0y, so the y will be eliminated, giving me negative 10 is equal to negative 10. Now, my variables are eliminated, therefore, I'll just need to consider this one. Now, what is this statement? Is this true or false? Negative 10 is equal to negative 10. Of course, that is true. And if it is true, then we have infinite solutions. Meaning that the nature of our system is consistent and dependent. Easy, right? So now, I hope you have learned a lot of things on how to solve system of linear equation using the substitution method. Now, this is the time that I will challenge you whether you have understood our topic for today, and here it is. Okay, math learners, I hope you have a wonderful time in our discussion for today. This is still your free access math teacher, Ash, and if you have some inquiries about the topic, do not hesitate to put your questions in our comment section below. I hope you can share this to your friends and other classmates that needs mathematics in the easy way. Thank you, God bless, and stay safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.